Picture a triangle, but not just any triangle, one with a perfect right angle, like the corner of a sheet of paper. Triangles just like this one are behind one of the most famous theorems in all of mathematics. To understand why this theorem is so special, we need to travel back more than 2,500 years to ancient Greece. There lived Pythagoras of Samos, a philosopher and mathematician, surrounded by the white columns and temples we still associate with that era today. Knowledge back then was often recorded on scrolls, written by hand and passed on, long before printed books existed. Pythagoras and his students studied numbers and shapes with great enthusiasm. And with right triangles, they made a discovery that still holds true today. If you draw a square on each of the three sides of a right triangle, something amazing happens. The combined area of the two smaller squares is exactly equal to the area of the large square on the longest side. This longest side is called the hypotenuse. The two shorter sides are called the legs. Mathematicians write this relationship in short. A squared plus b squared equals c squared. That is the Pythagorean Theorem. And here's the remarkable part. It works for every single right triangle in the world, no matter how big or small, no matter what it looks like. Here's a quick example. One side is 3 units long, the other 4, then 3 squared, which is 9, plus 4 squared, which is 16, gives 25. And the square root of 25 is 5. So the hypotenuse is exactly 5 units long. Let's try it calmly with different numbers. One leg is 5 units long, the other 12. Step by step, 5 squared is 25. 12 squared is 144. Adding both values, 25 plus 144 gives 169. And the square root of 169 is exactly 13. So the hypotenuse is 13 units long. It actually also works the other way around. If you know the hypotenuse and one leg, you can calculate the missing side. Let's take a hypotenuse of 10 units and a leg of 6 units. Then 10 squared, which is 100, minus 6 squared, which is 36, gives 64. And the square root of 64 is 8. So the missing leg is 8 units long. With a little practice, this will soon become second nature, and that's exactly why it's worth keeping this little formula in mind. This 3-4-5 triangle is so well known that almost every craftsman knows it by heart, and that's exactly where it becomes practical. Builders in ancient Egypt and Greece already used this principle to construct exact right angles, long before protractors existed. With a simple rope knotted into 12 equal sections, you could stretch a perfect 3-4-5 triangle, and with it, an exact right angle. To this day, craftsmen, architects, and engineers use exactly this principle. In house building, furniture making, anywhere exact, right angles matter. So the Pythagorean theorem is much more than a dry formula from math class. It's a discovery over 2,500 years old that is still used every day. From ancient temple building to the modern construction site. Simple, ancient, and surprisingly useful. That was the Pythagorean theorem. Explained simply.